Hello, good evening. I am Matt Lehman. You're here watching Building SaaS with Python and Django, and thanks for joining in tonight. We're gonna have some fun, I think. So this stream's all about working on a Python project, specifically a software as a service project called College Conductor. Software as a service is like membership websites that you can sign up, join services, and get some sort of benefit. College Conductor is specifically about college admissions and working for college counselors. We don't spend a ton of time focusing on the domain. You don't need to know a lot of the domain. I introduce it as we have aspects that need to be introduced, but I don't expect you to be a college admissions expert to understand what's going on here. But what we do is focus a lot on Python and Django, and that's what we're going to dive into today. So, yeah, there's I do encourage people to chat, people to ask questions. The purpose of this stream is really to teach and to get a chance to work on a side project a little bit. So that's the selfish interest aspect of it. But I want this to be an open forum, open discussions. I've got the chat open on the side. Just ask that you keep it civil, of course. But that's how this goes. If you enjoy what you see this evening and want to find out more about me in the future, I'm also on social media. I'm on MB Lehman on Twitter, on GitHub, on various social platforms, and I have a website which is listed above me. It's mattlehman.com, where I blog about various technical topics like Python and Vim and all sorts of other stuff. So let's dive into what we're going to focus on tonight. I brought up this issue. All of this code that we look at here in this entire software as a service is all stored in GitHub, aside from my secrets, although even though those are stored in GitHub too, they're just encrypted, so you won't be able to figure them out. But you can learn anything you want by checking out the code that's at this mblehman/conductor project. That is everything that powers College Conductor, all in a single place. So it's a gigantic, I guess, mono repo is the term. Some people may not like that, but for a small project it is very suitable. So we're going to look at the issues list on GitHub. I use GitHub issues as my place to track what I want to do, kind of spec out things. I don't have a big formal documentation process because really it's just a small project that is me doing design, development, everything. So this is mostly notes for myself, but I do try and put extra bits in here. So let's take a look at where I thought we'd start today. In the past few weeks, and just before I'll pause and drop this issue, this is where we're starting today. Someday I'll learn how to type and not speak it out loud when I'm streaming, but this just helps get my brain going. I will leave a note here. If you have any questions, please feel free to ask, because that's what this is about. So we are going to look at Ansible. Ansible, if you don't know, is a deployment tool. Even backing that up. So this is a web application. This is a service that exists at this URL. It is software that is hosted on DigitalOcean, which is a VPS service, a virtual private server. Is that the right term for it? But it's a place that you can basically have a virtual machine and deploy whatever you want. And so it's all wired up on the internet that way. And part of doing making a SaaS available online is having a mechanism to get your code from your local repository or whatever's posted on GitHub out onto the internet, out onto the server that's publicly available for anyone to get. And my tool that I use for that is the tool called Ansible. And I'll just bring it up so you can look a little bit at it. So Ansible's been around for many years now. It's a popular tool for doing deployments, and it is written in Python, and you essentially define all of your infrastructure using a set of tasks and stuff. And we can dive into a little bit of that. I don't know how much we'll need to explore today for what we're trying to do, but just to give you an idea of what happens is Ansible essentially targets specific machines on the internet, and it does a remote connection to them via SSH and sends Python code over that SSH connection, and then on the machine that it's on, executes that code to make sure you have your database set up and your web application going, and the right version of Python, the right version of your packages. Anything you need to do on the server is what the deployment tool is for. So Ansible is one popular choice. I actually think I saw some news article today even that said that Ansible has become perhaps the most popular deployment tool out there, compared to Chef and Puppet and other tools that are in the same area. I didn't look at the data to validate how they came to that conclusion, but it is certainly popular. That's one easy takeaway. It was a tool that was on its own. And Salt, yes. Yeah, Salt's a good tool too. It's a slightly different model. But Ansible is a tool that was a company that was on its own that was purchased by Red Hat within the last couple of years. But that's the guts of what Ansible is about. What I want to do today, and the reason I wanted to do this, is because I first wanted us to look at the tool that we've been working on. So I made this tool that will go over schools. I'm trying to collect some data, and I had this like sort of manual process, and I wanted to automate it and go faster. And in the last stream we did, we pushed out this code to production, and we tried it out. And what luck would have it, right? The very first school that popped up was a school that I didn't really want to deal with. Like College Conductor is all about US universities and colleges, and I was trying to collect schools from what are considered the Common App, which is a common application type that is used by a lot of universities. But there are some international universities that also use this application type. And College Conductor just really isn't dealing with international universities. So I wanted to essentially set that school aside and not worry about it. But the tool that I had made was limited in that way, such that you either processed it and made a decision and connected it to some other school that is in my database, or you didn't do anything with it. So it was too limited in what it was trying to do. And so the goal of this stream, my initial thought for this stream, was, okay, let's revisit that tool. We'll extend it a little bit more to be able to essentially take the schools that I don't want to do anything with and set them aside for later when I have more thought to do some deeper research on these schools. So that way, if there's a school that I encounter that's going to take more work, I can set it aside, and then I can crank through the easy ones so that I just have a set of harder ones when I'm ready to sit down and hunker down and do some research. But I realized that in this process of doing deployments, my deploy script is it's slow. Ansible is, it's a great tool, but it doesn't have a reputation for being super fast. And this problem only gets worse with the more servers that it has to connect to and send out tasks to do. So, and the last stream was evident of that. We sat around waiting essentially for a deploy to finish. Now, thankfully, I was able to talk through what we were going to do in the future, but really, I would just like my deploy to go a lot faster if possible. So I did some homework on ways that could happen, and I did some of the basic ones already. Like there's things and features that you can turn on. One of them is called pipelining, and these are various configuration options that Ansible can use to use more SSH connections to do smarter things about that stuff. But knowing that I'd already spent a little bit of time to optimize, I looked to see, is there a way that I could go even faster? And we're encountering at my current job where we've got a similar scenario where we have Ansible stuff that is taking longer than we want to. I probably can't quantify that because that's proprietary stuff, but just know that this is not the only place that I've had to deal with this problem. So I was doing some research on this, trying to solve this at work as well, and came across this project called Mitogen. And Mitogen sounds really interesting. And I didn't know a lot about how Ansible does its work, but my understanding, and this is, granted, I haven't looked at the code, so I can't attest to this for certain. I haven't seen the line that says do this, but my understanding is basically it makes an SSH connection. But if you look at the way Ansible runs its tasks, it's a series of tasks one after the other. And I think that each task sends the code for that task over the SSH connection so that it can be executed in isolation. A Python process will run, do whatever needs to happen for that task, and then tear down, and then the next task will happen. I think that's the flow. I don't know if any caching happens of that code, but I'm pretty sure that the Python process itself is on the other side, on the remote machine, is shutting down and starting back up for each of the tasks. And as you might imagine, Python is reasonably fast programming language, but it's not the fastest programming language in the world, and that's not what people praise it for. So that shutdown and startup time has a cost, and the numbers I saw. Oh, here it is. So the cost was that this project is claiming is that it's 300 to 800 milliseconds for every playbook step. So this project's really cool. It sounds like Mitogen. What it does, the alternative approach that it takes is it says connect out to SSH like Ansible normally does, but rather than doing a shutdown and a startup over and over, just keep a persistent Python process open or running, and then run all of the tasks within that one running process. So you're not incurring that up and down startup cost. And it you can see what they claim is a fairly significant amount of speed up. So I thought if I could test this out on my project, that might give me something I can go do at work or get a little bit of better understanding there. I kind of use College Conductor as a bit of a test platform for ideas that I want to try out. So I thought we'd try this. I want to go through this and see maybe the before and after. So I guess maybe one thing we should do is run a staging deploy and time it essentially to get a rough estimate. This is not going to be an exact benchmark by any means, but I thought that would be kind of a fun thing to do to see, can we get Mitogen going? And there's some caveats that you have to watch out for based on certain tasks that you do, but I don't know that I'm really running anything all that crazy in my deploy. I guess we'll find out if that's true or not. And we'll see if this works for us. So just going through here, some of the testimonials are pretty impressive. I don't know what's going on with some of these deploys, but these are kind of insane numbers, about 45 minutes to 3 minutes. My deploy is not nearly that long. When I do it out to my DigitalOcean droplet, it's probably like 3 to 5 minutes, somewhere in that range. But if this drops it to 30 seconds, then that gets the deploy cycle really cooking, which is appealing to me. So we are going to try this out and figure out which of these many notes about how this could go wrong will bite us or not. And then, so if you ever want to look at this project, if you're running Ansible yourself and you're interested in what's going on, they've got this interesting side-by-side video. And this video shows they're launching 2 projects. One is running with Mitogen, one is running without. And the one over here that's running with Mitogen is just cranking through. It's trying to get it through, trying to execute itself as many times as it can until this one completes over here. So it's able to go through it 10 times before the other side actually has any sort of issue. So, or any sort of completion. So let's dig into it, figure out what we need to do to get this going. And I didn't read this well enough to know all the steps in advance, so we're going to go through periods of silence, and I'll maybe read out some of these as I find out what we're doing to know how to do this. So I guess we should start at the installation section. And backing up, so I've mentioned this on many of the streams. There are times where you just have to read documentation. It's a aspect of being a software developer that you need to be comfortable with. So I don't shy away from reading documentation on the stream because I don't pretend to know it all. Like, I've been doing Python for a long time, but there's just too much to know. Like, you can be razor sharp and have a great memory and still not know everything there is to know about Python or the ecosystem, because the ecosystem is huge. So you have to get comfortable reading documentation regularly. And I'm going to be systematic and go through each of these things, and we'll see if there are any red flags that indicate to me that this isn't going to work. And then we'll run our little baseline to test it out and see what it currently is at. And then we will try and get Mitogen going. Okay. So let's start with the noteworthy differences. We're running Ansible through Python 3.6, I'm pretty sure. So let's come over to the code and we'll work on the conductor virtual environment. And I'm going to check Ansible version. Okay, we're running 2.6.3 with Python version 3.7. I think that fits in the realm of what this needs. Yep, it goes up to 2.7, we're at 2.6.3, and we're on 3.6. Okay. Ansible raw action executes as a regular Mitogen connection. Okay, I don't know what this means, but I don't remember any kind of raw actions in my deployment, so I think I'm okay there. I know there are some places where I use sudo, which is super user do, which is a way to elevate the command that you're trying to run on the other side. So maybe this will be a factor, but it seems like they are indicating that it's ready, so that seems okay. We're doing the SSH built-in connection, so I would assume that that's fine. The local command, I do have a local command that's at the end of the whole deployment, which sends a notification to rollbar, but rather than doing it from my remote machine, it does it from my local machine. So I don't know if that's going to bite us or not, but we shall find out. Module replacer style modules. I don't know what these are, and unfortunately there's no link of what to give an example of what that is. That's too bad. So there's a bit of feedback for the Mitogen person if ends up watching this. Can you explain what module replacer means? That would be cool. All right, Ansible does forks. Mitogen uses a fixed thread pool, so we could fiddle with that. First using, I think the Python interpreter, I set it to the Python 3 because I'm doing all Python 3 on this project and not Python 2. I don't know that that's going to affect us, but I should think it'd be okay. Performance does not scale linear. Okay, that's just a note about that, about performance. This has a note about timeouts with changing users. So in this deployment, I do have to become the deployment, the remote SSH connection has to switch from the root user to the Postgres account, I believe, to do some Postgres commands. So there is some places where become is used. That's Ansible's terminology for how do you switch users. But I don't know that that's going to be an issue. I guess it could be. There could be lots of things that go wrong. What did the install say? Did it also say to look at the known issues? Let's jump down there. Reboot, I don't think I do. I don't think I'm using a smart connection type. There's already that note about raw that we saw before. Okay, there's a lot of, well, we'll keep going. There's not that many nodes, I suppose. Note about performance. Okay, Python 3 performance is significantly worse, so maybe this won't actually buy us what we want it to. This is why we're going to run a test to measure this in advance. Actions are single-threaded. Okay. Some stuff about connections. There's some comment about pickle. I'm not wild about the use of pickle, but that's okay. I don't think it's. I trust the modules that I'm using, so I don't know that I'm too concerned about this. Okay, so there's a note that these connections, they start up and can leave stuff behind potentially if used in a different context, but that's more about the core being used somewhere else. So those are interesting notes. I don't know that I'd quantify those as like known issues that I'd care about for wanting to try this. I don't know why they're in here. Maybe I'm misunderstanding something. But it seems by a cursory scan, I don't think that took too long. That took, what, 5 minutes? To go through these notes and see, is there any stuff that is like a big, gigantic red flag? And yes, there are pieces that my deployment uses that might cause a problem, but none of them, it didn't say flat out anywhere that this should be a huge deal. So let's get going. I am bothered that it's a tarball. That's super weird. So I'm gonna search. Let's go to PyPI, because if you look at this, it's indicating, I'm looking at my URL down at the bottom, that these are files from pythonhosted.org, which is the place where PyPI files are served from. So I would suspect that Mitogen is available on PyPI, and it is. They haven't provided a package description. Oh, that's okay. So I think what I'm going to do is install. How can I do this? This is where it's going to get tricky, because what they're saying is download this, put it somewhere, and then use the Ansible config to point to it. Oh, that's going to be tricky, because I'm using, like if I say which Python, I suppose I could point to that, but I'm not wild about that. So that's going to be kind of annoying to make sure that the configuration is pointing at like a dynamic path. Pip install -target. So Anthony, are you suggesting like put the Mitogen package somewhere locally where I know it is? Yeah, okay. Yeah, that's probably safer. I guess I'll have to, if I do that path, I'm gonna have to think about like the bootstrapping of this. Like I want to be able to, because this Mac is now getting old. I got this in 2014. I totally imagine there's a future where, yeah, you could look up the site packages, right? Where my computer crashes and I have to get back to this, and I don't want to leave my website in the lurch. Okay, so I think I'm going to go with your suggestion of doing the pip install target, and we'll create, well, can I have, so I'm going to have Ansible coming from the virtual environment. I suppose it won't hurt to then have a separate virtual environment that has Mitogen installed. There could be a scenario where the Python version could be in conflict, right? So it's not going to be perfect. So I'm yeah. This might be where I take the time to like write some bugs. Like this should be a little bit more discoverable, I think. If I don't know, maybe there's a reason why this can't hook into Ansible more easily, and it's probably a tracked issue on the Mitogen repository wherever that lives. But yeah. Okay, so let's try. This is just an experiment, right? So let's do our benchmark, and then let's hack it in there. And if it works, then I'll clean up, because there's no point cleaning up if it's gonna blow up in my face or it's slower or something like that. So I actually do my deployments not straight to my production site, locally on my machine. And I use Vagrant to do that. So we're going to start Vagrant, or maybe it's already up, I don't remember. No, wasn't up. So when I run Vagrant provision, that will call Ansible and do all of my Ansible playbook stuff, but it'll do it to the virtual machine on my computer. The only reason that is the case is because I'm cheap enough to not want 2 droplets and not be paying twice as much of my DigitalOcean bill. I probably should just fork over a little bit more cash and have 2 places rather than dealing with Vagrant 2, but c'est la vie. Okay, so we've got time, right, to check how long something will take. So if we do time Vagrant provision, we should see how long this will go. And while that's running, let's take a look at the Vagrant file, just so you get an idea of what's going on. So I talked about Vagrant last stream, but Vagrant has this notion of, I guess, the 30-second version of what Vagrant is. Vagrant is a tool that lets you easily or quickly interact with virtual machines on your own hardware. So I have a virtual machine that has the same version of Ubuntu that I have on my live site. And Vagrant lets me start up that virtual machine, get into that virtual machine, work on that virtual machine, do everything I need to use it as like a test bed, because it's more realistic than running the code on the Mac OS version. So one aspect of Vagrant that is in there is this ability to do provisioners. And there are a number of provisioners. There's like, if you just want to run shell commands, there's a shell provisioner, there's Puppet provisioners, there's a bunch of stuff. Chef, I'm sure, because Chef is Ruby and Vagrant is Ruby, so surely that's part of this too. But Ansible is one of those provisioners, and you give it the playbook that you want to run. That's Ansible's terminology for like, here's the set of tasks that you need to execute. And then you give it the thing you want to run on, which is like, which servers do you want to target? And if I look at playbook development, Web01 is the name of the Vagrant virtual machine. So this is just saying, make sure you're pointed at the virtual machine. So you give it what you're pointed at, you give it some grouping information, you give it the playbook that you want to run. And here was the clever bit when I first hooked Ansible into this, was I had to line up my private key from the virtual machine along with the Ansible raw setting. Otherwise, they weren't quite playing nice to do deployment. So this is the magic line that took some banging of my head. All right, so Vagrant provision went pretty darn quickly. 23 seconds. So we might not actually even see that much speed up. And this sort of makes sense because this is an SSH connection to localhost. It's doing on the loopback address, so it essentially has no network hop in order to actually do its work. So yeah, we'll see if this is beneficial or not. So let's hack this in. Let's follow the steps of just downloading this, not worrying about pip, modifying the Ansible config. We don't even need to set the strategy, it looks like, because we can, well, we'll set it, we'll just follow what's in here. So we're going to save this and copy from the downloads, Mitogen to here, and extract it. Now we have a directory. So let's look at the Ansible config. And we need to change, I'm just gonna copy paste this stuff because it's pretty close. And let's see if it can do, hopefully it can do a relative path. That would be sad if it can't. Okay. Now the other problem with this is I don't actually know how this is going to work. Like, I don't know this is going to announce itself of now you're using Mitogen, unless of course it's like way faster, then that'll be obvious. But it's not self-evident of how you can tell the difference, because this is meant to be basically swapping out the connection engine of Ansible, of how it even does work, which is kind of a low-level thing that I don't think Ansible intended to do. Although they call it a strategy, so maybe it was intended. I don't know. But we've got it going. We've got the Ansible config going. So let's try the exact same provision and see what happens. So it could either go way faster, or it could fail spectacularly. Those are options. Or it could be about the same. I mean, maybe it's just me hoping that this seems faster, but it does seem... Okay. I think it's hard to tell. Because there's the other aspect of this is only going to save you the time for connecting, right? Like the actual time that it takes the plugin to do the work, that's not going to get better by this. It's not magically speeding up Python. It's really intended to shave off those milliseconds from each time that Python stopped and started. So I've got some tasks in here that are running a bunch of JavaScript code, so that's sort of unavoidable. But some of these do seem faster. Like it seemed like it cranked through some of those template things. I don't know. I feel maybe kind of good about it. Okay. What else could cause this to be faster? So it did go faster. We got 16 user, and I never understand how to read time well. Like, is this the total? I guess this is the total time, 135 versus 211. That was definitely faster. But, and here's the big problem, Ansible is designed to be idempotent. So, here's an example of this skipped task, but a lot of these are checking things, like if the repository changed, some of these things have to run again. And the second time that we ran it, we really didn't change anything. So we could have been getting, the speed up could have actually been coming from more skips, maybe? Oh, no. Now that I'm looking through them, how many skips do we have? Well, maybe there's less than I thought. So I might be prepared to call this just like an outright win. Okay. Let's see if this does what can we do? We could try a production deploy, which will then have the actual latency of going out to the internet, and see how that goes. That seems like a good idea. So the way that I do deploys is I run a makefile target of make deploy, and my make target, my makefile looks like this. It's just a thin wrapper around Ansible playbook with some switches and things that I didn't want to ever have to remember. So let's try it without for now. Let's go back into the Ansible config. And let's try commenting these out. And we'll see how long it takes. Oh, this is where it's going to be slower. So, as much fun as Ansible is to watch scroll by, I think we should probably focus on something else while it's running. So let's talk about what is it I was actually trying to do. So on the site, let me log in. Come on, LastPass. There we go. On the site, I made a tool. It's this tool right here. And I must have processed the school that was the problem. The job of this tool is to connect, like this school right here is a school that uses the common application. It's a type of application. And the schools listed below here are schools that exist in my database. And I wrote the tool so that it would tokenize, it would split apart the name, and then do queries on words that were present in the list of schools that I have in my database. And it would throw out stuff like university or college, stuff that like clearly was just going to turn up a ridiculous amount of results. And the goal was to show them all here, which it did that query. I'm curious, oh, you know what it is? Philadelphia has a Delphi in it, inside of it. That's what's going on. So that's why Philadelphia is coming up. Funny the things you see when you do this kind of stuff. And the whole point of this exercise was to say, like, given a school that does the common app, can I find the matching school in my database? We have a clear example right here. So I can hit connect, and it moves on to the next school. It's Agnes Scott. And I was kind of lazy about how I did the query, so I'm sure the way that this one worked out is it skipped college, because that's a word I told it to ignore, but it did a search for Agnes and it did a search for Scott. And so the first one must be the search for Scott, because we've got Scott and Scott in Prescott, No, I'm sorry. The first one must have been the search for Agnes and had one result. And then following two had Prescott and Scott as the two results. And there are like hundreds of these. So I'm supposed to go through and like click these along and find the university that matches. So far it's been, pretty easy going. These things are making themselves very self-evident. But what I encountered the very first moment that I ran this tool was Universidad of somewhere. I don't remember the school name off the top of my head. And I wanted to set it aside so that I wanted to basically create a new status in my tracking of these things of like parked, because I have a model that is keeping track of them. And you're either pending, like that's what these all are, they're unprocessed, or you're tracked, or you're some of these other states that I explicitly don't want to, like these are the things that will get filtered out eventually. But I wanted to just have a new status that says like, you're none of the above, and you're just like, I don't want to deal with you right now. And I didn't have that. So that was the purpose of going through this, which is, but before I can even get to this point, because I wanted to do it on production data, I wanted to have fast deploys. So here we are, we're still deploying, and I can tell you how many stages there are. So we have a database area, messaging, there's the node stuff, there's some third-party things that kind of run, and then we get to the web, and it's taking its sweet time. Why? Yeah, this is going pretty slow tonight. So I think what Mitogen does is it saves some of the time of the sending as well. Not only does it keep a persistent process, but if you think about the way some of these packages are, if Ansible is sending the code that it's going to execute for each task over every time, and that's a lot of data that's going down. I don't know that it's doing that or not. It may be smart enough to cache it during the course of the playbook, but I'm not sure. So if Mitogen says, just give it to me one time, and I'm going to just keep it running and load it, that would be really cool. But you can see this is really slow. And the reason I wasn't able to, I wanted to quickly iterate on this tool, but do it on production data and see like, can I park a school and consider it later? But if this was the time it takes to do a single deploy, that's kind of nutty. To at least do that streaming live. So I didn't want to do it, but here we are doing another deploy. Now, because of how much slower this is going than localhost, now I'm really interested to see if there's a big performance boost from using Mitogen. And if there is, they'll have made a believer out of me. So we're almost done, which is why I'm kind of hanging out here. The load balancer is like the last thing to go. Okay. That deploy took 7 minutes. That's crazy. Okay. So we can go back to the Ansible config. And this time we're going to see if Mitogen will make it go faster. And again, this isn't a true test because we're there might be some stuff that the deploy we just did already configured the site with new information, so it might skip some things. But I think that would only make like maybe a minute's worth of difference depending on how much it's skipping. So if we see like 2 or 3 minutes worth of savings, then I think this tool will have proved itself out. So let's try it. Now I'm going to watch it because I'm super interested. From watching this in the past, this definitely feels faster. Yeah, this is way faster. Well, it's kind of exciting that you can speed up a deployment, which is supposed to be like this critical thing, and you're releasing some code on the internet. And you can, just by making a few changes, you can get it to go a lot faster. And why? All right, so why do I say that? Let's unpack that. If a deployment is one of these things that brings with it risk. So if you're working with Docker or something like that, you have an image that you can kind of move around, and it's meant to be this artifact that you just sort of drop into whatever system you have, and it's done. Holy moly, 1 minute and 25 seconds. That is so cool. Okay, so we'll have to figure out how to make this stay. But if you're doing something like Ansible, Ansible's actually going out and modifying systems in place. And you can argue that that's a bad design approach, maybe, for doing deployments, but it's not an unreasonable design approach, especially when you have a smaller site. You're not working like on a gigantic microservices architecture that has tons of pieces in place that all need to be deployed at different times. This is more like a coordinated deployment. But the downside of this approach is that, talking to each of these servers and issuing out these commands, they have the risk that goes along with that. To give you a clear example, say we're working on a Django application, and let's say I had a big model, a model that has millions of records in it, and if you're a site that's been around for a long time, what model would that be? The most likely a model that it would be your user model, the model that tracks, in Django by default, the model that tracks the users that are on your site, your customers. And if you add columns to that table, and your site is doing queries for the user record, there is a time delay from when your web application server might be up and ready and when your database has actually run the migration on that table. And the longer that delay, the more bad stuff can happen. Because the way that Django works is if you try and issue a query that is not specifying the exact columns that you want, they'll basically do effectively a select star query. So a select all the fields. And if you've added a field and your code knows to it is trying to query for that field, because it's not literally doing a star, it's just enumerating each of the fields that it wants based on what's in the model. And so if I added a foo field, that's a terrible name, but if the Django code would say select user.foo from, or select foo from user where ID equals 1, something like that. But if your foo column doesn't exist in your database yet, then you're going to run into an error, right? Because it's going to say, this is like a programming error. You're issuing a select statement for a column that doesn't exist. What do you want from me? And so that's where you want to minimize your risk of, if you can shrink that time window down so it's as close to instantaneous as possible, then you get the benefit of not having as much potential for errors. I hope that makes sense. So by getting my time down, like by many minutes, it decreases the delta from like when my code is running with the latest models versions versus when my database has had a chance to migrate. So it's just a good thing to have faster deploys. There are all sorts of other issues that you can do to, or other things you can do to resolve those kind of issues. Like you could get smarter about how you manage your database, for example, of maybe you do what's known as a blue-green deploy, where you have different versions of your database and different read replicas and that kind of stuff. So it gets involved in a hurry, but the short version is you're always going to do better if your deploy is going faster, in my opinion. Especially if your deploy is exceedingly long. Like my deploy was 7 minutes. That's not a super long time. But if you have a deploy that's, let's say, 45 minutes to an hour, and you can bring it down to like listed in the Mitogen documentation, they had case studies where it was an hour and a half on 4 servers and it went to 3 minutes. That's like obscene change. And I'm sure it made their lives better. They're not sitting around with the anxiety of like, well, is it going to run? Is it going to fail? What's going on? So I think this is a really cool project from that regard. So now that I've convinced myself that it's worth keeping, let's figure out how we can productionize it to make it stay. Maybe the first thing I want to do is see if Ansible config has any sort of like dynamic attributes. Like what's listed here is to put the path here, but perhaps Ansible knows how to, well, maybe this isn't even Ansible. This strategy plugin. Let's see if we can do a search on that. Strategy plugins. Okay, so this is part of the Ansible doc, so that's good. Strategy plugins control the flow of play execution. Okay, that's exactly what Mitogen is doing. It's changing how stuff happens at the connection level and how plays are executed. And we're looking for, well, they've got the strategy line here. Where is, like the name of it was strategy underscore plugins, right? Yeah, strategy plugins. By putting it in one of the lookup directory sources configured in Ansible. Oh, this is promising. So maybe they're search for lookup. There's a bunch of these. So maybe it's one of these things that if we can install it in like the default plugin path, then we don't need to do anything clever in the configuration file. So it just needs to be something that the system can find. Default lookup plugin path. Well, there's one, but maybe this can be configured too. What's the difference here? All right, so that appears to be the only thing that it can go with. So but we take the default value and we take so let's say the INI key was lookup plugins, and we can set it to that. So it's still going to be the default, but what I'm going to do is prefix it with the path that I care about. So now we just need to decide what is that path that we care about. Maybe playbooks, plugins. That seems like a reasonable place to put stuff. Let's do playbooks. Come on, type plugins. The question is, I'm just thinking through. Sorry, I'm not thinking out loud as I should as a streamer. The question is, once we have this lookup for plugins, how does it know to find a strategy plugin? Like this is we've given it the path to the strategy plugin, given it a directory. And I was hoping that basically I could say, put all of the plugins for Mitogen into the plugins directory, but I don't think that's not going to wire it properly. Okay, so maybe that's not the right approach. Let's try Anthony's suggestion of pip installing using the target option. I don't actually know target, so let's read what it target. Where are you? Okay. Install packages into directory. Okay. So let's put this let's codify this in the make file. And I'll call this bootstrap, because this is, if I ever needed to start over, this is what I would do. And now we're going to pip install the target. The place that I want to put that is playbooks. This will be what? Playbooks virtual env. And we'll do Mitogen. And should I pin it? Probably to be safe, I will pin it to 0.2.5 because I'd rather have stability over like whatever cool new features they come out with. We'll say full 0.2.5. Okay. And now if we come out of here and do make bootstrap, did I say bookstrap? Playbooks VM. Okay. Bootstrap. Cool. I installed Mitogen. We have a new directory that we're going to want to ignore. Let's do that now. The playbooks has some stuff in it that I already ignore. So we'll say ignore playbooks env, and let's be alphabetical. Okay. I'm gonna remove the Mitogen stuff. That's gone. And now let's inspect what we have in the playbook area. So playbooks, virtual env. Oh, cool. Just puts it, I like target, that's cool. I was expecting the whole like virtual env structure. This is better. Playbooks, Mitogen. What was the path we needed? Ansible Mitogen. Okay, so Ansible Mitogen. Plugins. Strategy. Okay, cool. So that's the path we're going to want to put in here. Change this to playbooks, virtual env. Virtual env is really, that's kind of a lie. It's not really what that is. Because a virtual environment is got the whole structure of Python with like site packages and everything. So yeah, I don't think I want to call it that. Instead, let's call it playbooks. What's a better name? Plugins? I don't know. Slightly better, maybe not much better. Come back to getignore. Change it to plugins. And this is killing me because now I'm not alphabetical anymore. Yeah, not quite a virtual env. It's really cool. Thanks for pointing it out. I'd never heard of using target. I like it. Seems really convenient for the right scenario, and this is a really good fit for it. My brain is sort of all over the place at this point, though. So let's go change that makefile and change this to what I just say, plugins. And our Ansible config is now should be pointing to plugins. So I think this is the right path at this point. I guess we could test this again by doing another deploy. Oh, very cool. It does seem like a handy use for it. I need to explore more of pip. There's more in there than I realized, probably. Okay, so I think what I want to do is try deploying again. And I don't know that we're going to go all the way through it this time because it was so much faster that we can probably deduce if it's doing the right thing in just a brief time looking at it. Yeah, it's the same thing. And I'm so impressed. The other thing I need to do, which we won't do today, I need to build, I don't need to. I would like to build my JavaScript in CI. Because right now what happens is I am installing Node on this droplet just for the purpose of doing an npm install and an npm build, or whatever I called my npm command to generate my JavaScript files and make my Webpack bundles. It's this step right here, build front end. So these two steps happen to be a couple of the longest steps. Like if we got this thing down to a minute and a half, maybe it'll shave off another 10-20% of that just by doing that. So I'd love to be able to say, CI, you build my JavaScript files, in the right tagged way and put them, I don't know, on S3 where I have a bucket. And then during the deploy, rather than needing to have JavaScript installed and having more surface area on that server, I could instead just have it go out to S3, pull down the JavaScript files, and put them in the right place. Yeah, that 1 minute and 30 seconds. That's very pleasant. Okay, cool. So let's see. We've, I think I spent basically an hour and 10 minutes to make what, 5 lines of code, if you can even call them code. This is really just configuration. This is software development for you sometimes. And I think that's probably a decent enough place to wrap it up. So going forward, we now have a nice faster deploy, so that rather than not go sit through a 7-minute deploy, we have a 1.5 minutes. So we, however much speed up that is more than 4 times, right? Don't quote me on that. I'm doing the math wrong. Yeah, that'll be really useful in the future. I think what we will do next time is revisit this tool. I might actually go through it some until I get to a school that we can really illustrate the problem, because so far they've just been refresh, and yeah, so far they've been easy, which is the problem. You know, that's a good problem for me to have, but yeah, cool. So if you have any questions for me, happy to answer them now or on Twitter if you want. Let's declare success on this. I can go ahead and commit it, and we'll wrap it for the evening. Make Ansible go way faster with Mitogen. I'll have to give them a plug on Twitter, because that was just cool. I'm super impressed. And this is 369. Cool. That was this issue. Next week we will get back to issue 368. We'll clean up those edge cases, and then hopefully work through the thing that I wanted to work through, which is getting to this cycle of, like, can you make some quick changes, do a quick deploy, see it on production, and iterate. I think a lot of companies don't like even the idea of moving that fast is crazy to them. Like, it's very freeing if you can actually rev at that speed. And perhaps we should talk about, like, you know, it's nice to be able to go that fast, but this thing that I'm working on, this is like a back end. This is a tool that is just meant to be a tool for me to crank through some stuff like that fast. So it's not pretty, it's not glamorous, and if I screw it up, you know, short of me breaking the server entirely, which shouldn't happen because I have continuous integration to give me at least sanity checks to know if I broke like imports or something like that. But there's still the problem of, you know, if you have users on your site and you're deploying fast, how do you make sure that on production pages, like real pages that users might care about, like for them using the tool, you know, if I'm working on this table and I'm fiddling with these things, how do I make sure that my users don't see me fiddling with things? And the way to do that, or a very common way to do that, is with feature flags. So yeah, let's make that as a new issue. Let's talk about College Conductor isn't actually using feature flags, but it's a good system to have available. So let's add a feature flag system to College Conductor. I'll just say Conductor. And the tool that we'll look at is called Django Waffle. So there's the teaser. Or if you just want to research it on your own time, it's a really cool tool. So that's what we'll do next week. We'll make the tool better that we're working on. And I'm not going to make everyone sit through as I go through hundreds of schools and find out more problems along the way. That would be silly. But we'll find some good choice examples of things that will help me in the future. And after we get through that, hopefully that won't spend all the time. After we get through that, we'll talk about how to add feature flags into a system to let you work on code that is production, release it out with confidence that your users aren't going to see it until you're ready to turn it on for them. That's the flag aspect of this. You're turning things on and off. So that brings us to the end of the stream tonight. I hope you learned something. Hope you had a little bit of fun poking around at Ansible. Hope you enjoyed it as much as I did to see something go way faster. I always get a kick out of doing performance things like that. It's kind of a fun process. If you want to follow me on Twitch, I am right here. So you can subscribe and get notifications about when I stream in the future. I'm also available on Twitter as MB Layman. If you want to message me there, I'm happy to chat about any technical topics. The stream itself, this recording, will go out on YouTube in case you want to refer to it in the future. And I think that's about it for tonight. So thank you so much for joining in. And with that, I'll see you next time. Take care.